Hello everyone, my name is Arun Yadav. Here I will explain you liver tumor segmentation in CT scan images using the UNET and ResNet model. According to research, liver tumor are the fifth most common cause of death in men and ninth most common cause of death in women. But through deep learning, we can easily detect the liver and tumor. For this experiment, we collect the dataset from Kaggle, which is 131 images of CT scan in the format of NII, and the original source of dataset is LITS. LITS challenges. LITS stand for the liver tumor segmentation challenges. After the 2017, this challenge is held every year because it's very difficult to segment tumor as well as liver from the CT scan images. Let me show the original image in Mango. We can't easily detect where is the position of the liver and the tumor, but in the segmentation image we can easily detect where is the position of the liver and the position of the tumor. The white patches is the show the position of the tumor, and this is our code for the liver tumor segmentation where OS and Global library used to get the data. Nibble library used to convert CT scan images into array, and pandas and numpy library used for the data processing. After data processing, we we can see that we find original image, window image, mask image, and liver mask image. For training and testing data, we use FastAI. Here we use two deep learning architecture, UNET and ResNet. We use UNET architecture for a biomedical segmentation. Let's discuss about the architecture of UNET. They divide into two parts, decoder and encoder. The decoder, the channel is increasing and the pixel of the image is decreasing. In every downsampling, we can see that we add the max pooling layer, and after every convolution layer we add the ReLU function, and in encoder is the vice versa of decoder. In upsampling it retains the original pixel of image. Here we also use ResNet, is also known as a skip connection because we can see in figure it skip the connection from the activation layer to the next layer. We use this to resolve the Venice gradient problem. And to evaluate our model, we use dice loss function. This is all about how can we detect tumor segmentation.